For our second practice problem, we've got a question that says in triangle ABC, M and N are the midpoints of AB and AC respectively. Now we can clearly see that because on the left hand side where we have AB, M is the midpoint. We can see that AM and MB are equal to each other. And on the right hand side, N is the midpoint of AC. Here you guys can clearly see that AN and NC are equal to each other. Now we are required to prove the theorem that states that MN is parallel to BC. Now you guys need to ask yourselves, which theorem is this? Which theorem states that MN and BC are parallel? Now by looking at this diagram, this should instantly remind you of the midpoint theorem. So you guys know what the midpoint theorem is. It says that if a line is drawn from the midpoint of one side of the triangle to the midpoint of the other side, then it should be parallel to the third side. Now we are going to use this question as a walkthrough of the proof of that theorem. And the first thing we're going to start off with is a construction. So here's what we're going to do. Where we have this line MN, we are going to draw a line that is the same length as MN. So whatever the length of MN is, this line needs to be the same. And you are going to attach that point to C. So basically what you're doing is you are creating a triangle where this length, now you can name this corner MNO or P. Let's go with P. So let's name this P. Now you guys, when it comes to proofs, so you are being introduced to proofs this year. You will have a lot of them next year as well as in grade 12. When it comes to proofs, and if ever you draw something on the diagram which was not given to you, that is known as a construction. So any construction that you fill in on the diagram, you need to state it. Remember, the person marking this needs to know where exactly are you getting this from. We now see this extra triangle, NPC. NPC was not given to you. You drew it on your own. So as a starting point, let's mention that construction. So this is how we do it. We say construction. And I'm going to say draw triangle NPC such that MN is equal to NP. Okay, we drew the triangle in such a way that this line MN is equal to NP. Next, here is our aim. We need to prove that this new triangle that we've drawn is congruent to triangle AMN. Now, what do we mean when we say that triangles are congruent? We mean that they are exactly the same. So this is what we're going to do. I want you guys to notice that angle ANM, so this, is equal to angle PNC. Angle ANM is equal to angle PNC. Why would they be equal to each other? These are vertically opposite angles. Just to remind you of the names, we're going with ANM and PNC. Vertically opposite angles. Now, since we are trying to prove congruency, we see that we already have an angle. Then we can see that AN is equal to NC. That is given. And we have another pair of lines that are equal. MN is equal to PN. Now, where does MN equal to PN come from? That comes from our construction. Now, you guys notice that we've got three reasons here. And what you actually can do is, if you want to mention the triangles that you're working in beforehand, you can do that. I feel like that would structure our work a lot better. So before you start off by proving that the triangles are congruent, maybe state which triangles you're working in. So we can say in triangle AM, in and triangle PNC. And here are our three reasons. Now you guys notice that you've got an angle, side, and a side, but when it comes to congruency, there are specific ways in which the letters are written. So we cannot go with angle, side, side, but we can go with side, angle, side. Now why does that make sense? If you look at your diagram, this angle is between two sides. So we've got a side, angle, and a side. Same thing on the other triangle, side, angle, and a side. So when we state that they are congruent, we're going to say triangle AMN is congruent to triangle PNC, and we used side, angle, side. Now the next question may be, how does this help us to prove the midpoint theorem? We were able to prove that these two triangles are congruent, but we are not yet done with this proof. Remember, ultimately, what you are trying to prove is that MN is parallel to BC. Now, you guys, one more thing we notice from the congruent triangles. Congruency, remember, means that these two triangles are exactly the same. So if they're exactly the same, where we have AM, AM would be the same as PC. And remember, AM is also equal to MB. So let's actually mention this. Let's mention that AM is equal to PC, since the triangles are congruent. Now actually, I think I'm going to use a different color for this so you guys can see which step corresponds to which color on the diagram. We're going to mention that AM is equal to PC. And our reason for saying that is that these two triangles are congruent. Now, how does that help us? Since AM is also equal to MB, we now see that in this shape, we now have MB being equal to PC. So this now means that MB or MB is equal to PC, and also MP is equal to BC. So the two long sides are the same. MP is equal to BC. So you guys, by showing that these opposite sides of this shape are equal to each other, what have we actually proven? We've proven that this is a parallelogram. We've proven that this entire shape, MPCB, is a parallelogram. Therefore, MPBC is a parallelogram, and that we know because we have two pairs of opposite sides equal. And you guys, we're now at the last step. If we have a parallelogram where we have two pairs of opposite sides equal, what does it mean with regards to the sides being parallel? We know that opposite sides are parallel, and that is exactly what we needed to show. We needed to show that MN is parallel to BC. So all we have to state now is that, therefore, MN is parallel to BC. And your reason is opposite sides of a parallelogram are parallel. And that's it. We have proven that MN is parallel to BC using the midpoint theorem.